Okay, let's do some practice problems here. So what we have here is we have a circuit. We have our power source here, and symbol for a battery. It's 50 volts. And like we said, voltage is the equivalent of the pressure. Right? That's the pressure that's going to push the electrons out and through the rest of the circuit. And the current is what we're looking for. And the current is the flow of electrons. Our load is a light bulb, and that's 100 ohms, and that's the resistance to the flow of electrons is 100 ohms is the unit. So how do we find the current in this circuit? Well, we use Ohm's law, and if we use this triangle here, that helps us to remember Ohm's law. Alright, so we can look at it like this. Whatever variable we're looking for, we just cover it up. In this case, it's I. So I equals, and you see V divided by R. And just to show you, if you were looking for resistance, that would be voltage divided by current. And if we were looking for voltage, that would be current times resistance. So that's how we use this little triangle chart. It helps us remember Ohm's law. So in this case, we're looking for the current, and that's the current equals the voltage, the 50 volts, divided by 100 ohms, which is going to be 1/2 of an amp. Or we could say that's going to be 0.5 amps. We want to look at it in decimal point. Or we could take that 0.5 and move the decimal point 3 places over to the right and call it 500 milliamps. Milli being 1,000, 500 thousandths of an amp. Right? Half an amp, 0.5 amps, 500 milliamps is all the same value. Okay, let's look at another example. So we found the current there. Let's look at a problem where we're given the voltage again, and we're given the current this time, and we have to find the resistance. Again, I'll use a light bulb as the load, or we could use a resistor there. Our voltage is a 12 volt battery. And we know we have 2 amps going through the circuit. So whatever current is leaving the source and going to the load, same amount of current coming back. Happens to be 2 amps. Amperes, I call it amps for short. Right? And we want to know what the resistance is. So what does the resistance equal? Well, that's going to be the voltage divided by the current. Right, Ohm's law. So we plug in the numbers, 12 volts, 2 amps. So the resistance has to be 6 ohms in this case. Omega is the symbol for ohms. Okay, let's do one more problem. So we solved for the resistance. Previous problem we solved for the current. Now let's solve for the voltage in our next example. Here's our power supply, but we don't know how much voltage that power supply is. Right? I'm going to put a V equals, and we get a question mark there. Okay? Let's say we know that bulb is a 20 ohm bulb. Right? And you know, it's not an LED, it's old-fashioned incandescent type that you could just pull out, put an ohm meter across, and you measure it as 20 ohms. And you plugged it in and it lights up, and you also used an amp meter, and that amp meter told you that you got 4 amps going through the circuit. And if you wanted to calculate the voltage, how would you do that? Well, using this triangle again, if you don't have Ohm's law memorized, you could go V, voltage equals current times resistance. Times resistance. Plug in the numbers. Current is 4. All right, plug in the current. That's 4 amps. And we're going to multiply that by 20 ohms. And that gives us 80 volts. So the power supply here must be 80 volts if we have a 20 ohm lamp drawing 4 amps of current.